Lesson 2.2, the greatest common factor. Common factors are factors common to any two or more numbers. Identify all the factors of each given number using divisibility rules can help find the common factors of the two or more numbers. Remember, the last video is all about divisibility rules. Like example, what are the common factors of 24 and 36? Here's factors 1, 2, 3, 4, 6, and 12. We can use the common factors 1, 2, 3, 4, 6, and 12. We can use from common factors. What are the common factors of 8, 12, and 16? There's 1 and there's another 1 here. There are 4s in each side. The common factors are of 8, 12, and 16 is 1, 2, and 4. Once you find all the common factors of two or more numbers, you can identify the greatest common factor. The greatest common factor, or GCF, is the biggest number that can exactly divide two or more numbers. What is the GCF, or greatest common factor, of 24 and 36? Well, let's find out. Look at this. So there's 1, that's 2, that's 3, that's 4, 6, that's 12. Just like the same one as the example number 1. And then the GCF is 12. So 12 as the GCF, or greatest common factors. This means that the greatest number that can exactly divide both 24 and 36 is 12. So 12 is the greatest common factor, or GCF. It's just like example number 2 from common factors. Now we use GCF. So the GCF is 4. So GCF is 4. It means the greatest number that can exactly divide 8, 12, and 16 is 4. So 4 is the greatest common factor, or GCF. Note that when two or more numbers that considered have the GCF of 1, the numbers are called relatively prime. So exactly what you need to do is the GCF is 1. So only you use 1, okay? That will be 1. Make it a relatively prime. So the relatively prime. So only 1. As seen in the examples, knowing the divisibility rules that can help find factors, common factors, and greatest common factors of two or more numbers. This method, where all the factors of the given numbers are being listed, is called the listing method. The listing method is using the prime and the composite numbers. We can use it to multiply. For example, 16. So it's 2 times 2 times 2 times 2. So this one, it will be same as it. And it will be composite, it's 9. So that's 3 times 3. That will be the same as this one. There were 2 prime numbers. So 3 plus 3 is 6. Because we need to add things, okay? Another method in finding the GCF of two or more numbers is using continuous division. division, you need to divide first, then you need to continue. In this method, the given numbers are divided by their common factors or not necessarily prime continuously until the results and relatively prime. For example, find the GCF of 24 and 36 using continuous division method, because you need to divide first 24 36. You need to divide into 6, so 24 divided by 6 is 4, 36 divided by 6 is 6, so we need to divide into 2, so 4 divided by 2 is 2, 6 divided by 2 is 3. Because 2 and 3 are relatively prime, the continuously division stops. To get the GCF, multiply all the common factors on the side that are used as divisors. So 6 times 2 is 12. So 12 is same as the GCF, like listing method and it continuous division, because the 24 and 36, so 24 first, so it looks like 2 times 2 times 2 times 2. No, that's not right. That only 3 times 3 times 2 and so on, but no, you cannot use it. So only a 6 and 2, right? So we can use 6 times 2 is 12, so I can use from it. Find the GCF of 8, 12, and 16 using a continuous division method. So 8 times the 8 divided by 2 is 4, 12 divided by 2 is 6, 16 divided by 2 is 8. Now we need to divide by 2 again. 4 divided by 2 is 2. It looks like 1, but it's okay. You can use 1. But 1 times 2 is 2, so nah, you cannot use that. 6 divided by 2 is 3, and 8 divided by 2 is 4. But it's messed up. Who did this? The book. GCF, it will be 2 times 2, it will be 4. So GCF is 4, is same as this one. Area of the problem. Miss Baganiban has 48 pencils and 32 ball pens. She wants to distribute all of these to a certain number of peoples. Each people should receive an equal number of pencils and the same number of ball pens. What is the greatest number of peoples that could receive the writing materials? So let's find out with using apps. What is asked? Greatest number of peoples that could receive the writing materials. In the problem or probe, there are 48 pencils and 32 ball pens. The items should be divided equally among the peoples. Each people must have the same number of pencils and the same number of ball pens. Now we need a plan. Find the greatest number that can divide both 48 and 32. This number is their GCF. Use continuous division to find the GCF of 48 and 32. Let's go and find out what are solved. need to divide into 4. 48 divided by 4 is 12, and 32 divided by 4 is 8. Now we need to divide into 4 again. So 12 divided by 4 is 3. 8 divided by 4 is 2. This is GCF is 4 times 4 is 16. The greatest number of people that can receive an equal number of pencils and an equal number of ball pens is 16. Aside from the listing method and the continuous division method, is there another way to solve for the GCF of 2 or more numbers? So for the GCF of 24 and 18 using another method on a sheet of paper, I give you a hint. The hint is you might use prime factorization of 2 numbers to get their GCF. What is prime factorization? Let's find out. Prime factorization is the process of expressing a number as a product of its prime factors. This is done by factoring the numbers continuously until all the factors are prime numbers using a diagram called a factor tree. Using prime factorization, you can get GCF from 2 numbers. Like for example, what is the prime factorization of 40? So the first one, the primary is 5, so the number 5 is the prime numbers. This is the first one. The first one is 5. That is the prime number. Next, we need to divide again. So we have 4 and a 2. So the number 2 is the prime number already. Then we use the 4 again. So 2 times 2. So both factors are already prime. So the prime factorization of 40 is 2 times 2 times 2 times 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. It's also correct. Let's try the last one. Find a GCF 60 and 42 using prime factorization. First step, make the factor tree of each number. 60, it will be 6 times 10. We both got composite numbers. We need to split up again. So times 2. So both these factors, it will be prime, and this one's also prime too. And 42, it will be 6 and 7. There's 7. The number 7 is a prime number, and the both of them already in the prime numbers. List the prime factorization of each number. So 60, it will be 2 times 2 times 3 times 5. So 60. 42, it will be 2 times 3 times 7. So 2 and 2 and 2 and 3. So we can use 2 times 3. So it's 6. That because it will find the common factors of the 2 numbers. They multiply these common factors. So the GCF is of 60 and 42 is 6. So 6, it will be a GCF. Go on the book, it will go in Skill Booster by pages 42 to 44. So we can use to do right things to do. So do you remember the GCF? Meaning the greatest common factors, we need to find the common factors and GCF or greatest common factors. Then you can use prime factorization and continuously division and listing. In our next lesson, 2.3, we'll talk about least common multiples. I hope you have a really wonderful day. Join me and see you next video. Bye!